Hi guys, Shah here, the TechBorg, and again back to A-level maths videos. And yeah, so let's crack on. I mean, this video is actually about sequences and series. I should be actually doing this video before my differentiation one, but I thought differentiation would be just more fun for those of you that actually enjoy maths. So yeah, let's try sequence and series. It's not that hard. I mean, the basic thing you need to know is, okay, so imagine we had the sequence 1, 2, 3, 4. Okay, so it's going up in 1 every time. So we know that the difference is 1. So D is equal to 1. So D is the variable for difference. A represents your first term. So this is the first term. So it's A is equal to 1. So A is equal to 1 and D is equal to 1. And that's it. Simple. That's the basic things you need to know. If the series is arithmetic, and in this video only arithmetic series, just to keep it simple, and I'm going to make multiple videos on each different type of series, the type of questions that can come up and how to problem solve those questions. So if I just quickly zoom out, make the page slightly bigger. Okay, so UN, it represents your term. UN, the N is your term number, right? Term number. So never forget that, term number. A UN is the value when you plug in N into the formula. So UN represents formula, so 2, 4, 6, 8, etc. That's going up, that's adding 2 each time. Yes. So you know that, according to GCSE knowledge, you'd probably do the difference, which would give you the nth one, so it'd be 2n, and if you go 1 back is 0, so plus 0, so it's just 2n, so it would be 2n, right? But in A levels we have to do it slightly differently. So if I just remove this section actually, so I just cut that, crop. Why did I just crop that? Okay, anyway, so in A levels you have to do, sorry about that, UN is actually equal to A plus N minus 1 D. Now you need to know how to get to this point, which I'll show you right now. Or should I make another video on it? I think it's better if I just show it in this, combine it. So if we just make this slightly bigger. So let's say we had a sequence, okay? The initial term is A, okay? Imagine that the difference was just D. So it'd be A plus D, right? Because you're adding the difference. So imagine we add it again. So A plus 2D. And then A plus 3D. This is the first term. This is the second term. This is the third term, fourth term, etc. So we have A plus D, A plus 2D. And these dots just represent until n gets to infinity. So as n gets to infinity, well, it would be, as you can see, this number is always 1 minus the value over here. So it'd be just A plus N minus 1 D. So N minus 1, why? Because again, it's minus 1 the nth term. So minus 1 from this gives you 3 here. Minus 1 from the 3 here gives you 2 here, and so forth. So now, a cool thing happens. If you flip this now, okay, A plus N minus 1 D, blah blah blah. I'm not going to write these middle terms, straight to A. So now, if you think about adding these two together, what do you think will happen? Well, the best thing that will happen is all of these will cancel. The A over here, the A plus D over here cancels with the A over here. The A plus 2D will cancel with another value over here, and it will keep on going. A plus D. So if you think about it logically, obviously. So let's see, 2UN. So if you add these two sequences together, this will cancel with the value over here, this will cancel with the value over here, this will cancel, etc. And you'll be left with n lots of this value. So, but the only thing we'll have left in the end is A plus N minus 1 D and just A. So if you add these two together, you get 2A plus N minus 1 D. Okay? And actually what we're doing here is we're actually finding the sum of a series. I just realized, yes. So we're actually proving that the sum of a series is this. So this is the sum of a series. You need to know this, obviously it's a proof, sum of series. So yeah, But don't forget you'll have n lots of these, because remember you cancelled quite a few of them. By cancel I mean when you keep on adding a plus d to that plus that, you'll be left with n lots of these terms. If you think about it, if you're not sure, write down all these terms and add them to all the terms over here. So write down like up to a plus 4d, a plus 5d, and you'll be left with quite a few a plus n minus 1d's, and you realize there'll be n lots of those terms. So if we do un is equal to n over 2, because if we rearrange this we can get un by itself. So un is equal to n over 2, 2a plus n minus 1 d, and that's it. But this isn't un anymore, is it? No, it's Sn, and Sn just means sum of, and this is getting very messy, so let me just rub this section out because we no longer need it. Crop. Okay, we just remove the important bits, but it's fine.